Today, we will study in details the procedure of flaw detector PE4332 calibration as well as the beginning of measuring a test object. First, we will calibrate a sensor. The sensor has the strong magnetic field, so we will take it away from all metal objects, for example, by raising it by more than half a meter above a pipe. Start the air calibration mode. The sensor will be automatically calibrated just in no time. You will need to repeat the air calibration of the sensor when replacing it or when the ambient temperature changes significantly, for example, when it either rises or drops by 10 degrees Celsius. Now, we will calibrate immediately on the measured item. Go to the menu of the test object parameters and set the item we want to measure. The shape of the test object, pipe or sheet. The material and thickness of the casing, if any. The nominal wall thickness at the point of calibration. The insulation thickness and insulated pipe diameter. We recommend to take these parameters from the item data sheet or, if possible, to determine them directly in the point of calibration. The device does not require the absolute accuracy in setting all these parameters and will correctly operate even, let's say, with an insulation thickness error of 20%. However, the more correctly we will specify the test object, the more precise will be the measurements of thinning in the areas with defects. And the final stage of calibration, let's install the sensor on the item at a point with no expected defects and, accordingly, with the wall thickness as specified in the data sheet. Switch the mode to calibration. The device will take several measurements and display the measured value and a diagram of the item demagnetization. Calibration is completed. The device will use this calibration data as a reference for further measurements. If we see the wall thickness in the any item area greater than we have got during the calibration, then, it is possible, we calibrated in the area with a defect, so we should recalibrate after selecting the point for calibration in another area. As you see, we do not rotate the sensor when measuring the item. The magnetic field has a complex spatial geometry, so, with significant rotations of the sensor relative to the item, we can lose the accuracy of measurements. Our item for demonstrations has different wall thicknesses in different areas, so we can show how the demagnetization curve changes depending on the thickness of metal. As the thickness decreases, the curve moves noticeably to the left. And, as it increases, the curve shifts to the right.